This is Serb Atheist, and Graydon Square has inspired me to do a video on future technology and the future of science. I mean, this is of course a very fascinating subject on what the world will be like in 20, 30, 100 years, and in fact probably a lot of it will change. But I have a few things to say on that matter. First of all, the progress of the humankind has never been neither uniform nor inevitable. True, people could not have predicted cell phones and all very fancy gadgets that we have today. Although they have been predicting the video phones for quite a while, and only recently are these things actually starting to become viable. But for example, someone in the 70s predicting how far we would go into space would have probably predicted that by now we'd already be colonizing Mars and exploring Jupiter and so on. And just based on the lightning quick progress in the 60s, and these things, for many reasons, have not happened. So, and of course there have been, even though we have a global civilization today and the chance of a civilizational collapse is minimal, unlike before where you had many tiny isolated civilizations, nothing about progress is inevitable. It could quite be conceivable that we would mess things up in some sort of a nuclear war and lose our technological progress. Now, as far as I can tell, humanity has been progressing in fits and starts. So in every age you have, it's not uniform. In every era you have some area of science that is going lightning quick while others are barely crawling at a snail's pace. Physics has been the star science for much of the late 19th and in more or less most of the 20th century. But it seems that we have exhausted things to discover in physics. Not that we still don't have questions unanswered, it's just that to answer those questions, we simply don't have the technology necessary to construct an accelerator large enough. I mean, today's situation it would be unusual for us to remember that just 100 years ago it was actually experiments and experimental results that were far ahead of theory, and you had all these unexplained phenomena that needed to be explained. Now theory is ahead of experiment, so physics will just for that reason stagnate for quite some time. If the new accelerator finds the Higgs boson and it confirms the predictions for its mass and so on, and the standard model ends up being like complete and tied up into a nice hole, you'd have to probe far deeper to find anything else. So that's a problem. And as far as non-fundamental physics, that will continue to chug along. I mean, finding the theory of everything, which I think will happen in like 200 years or so, will not hamper physics, because physics is not just about finding theories which explain our universe, but also fleshing out consequences of these theories, where the job is almost infinitely difficult and infinitely long. So I think most progress in the next century will be in the realm of cosmology and in the realm of gravitation and refinements to general relativity, perhaps, when we discover gravity waves and other phenomena in the cosmos, and of course planetary detection. Those are the hot topics. The most important science for the 21st century is probably definitely going to be biology. We're going to be making major breakthroughs in biology, and we already have begun, and this wave of quick progress does not show signs of slowing anytime soon. From recent news reports and what I've read before, within the next 20 years, there's a great chance that we will be able to create synthetic life. So first life, living beings that we have made from scratch, thereby debunking many of theists' arguments about how only God can create novel forms of life. That won't be true. And these, all life today essentially uses pretty much the same alphabet and the same language to form a description of itself in the genes. So it's always the same for basic amino acids, and it's always the same for all living organisms. These amino acids are formed into codons in exactly the same way. Well, in new life, we're going to have different amino acids, different ways of reading the codons. It's going to really stretch our limit on what it means and on our understanding about what it means to be a living organism. And of course, medicine and gene therapy, I think we're going to have a Gattaca-like future where people will be able to select their genes and genes for their children, which actually is a good thing. Genetic diseases, horrible, such as Down syndrome, cystic fibrosis, all of these will be a thing of the past, I think, in the next century. And in general, humans will be able to select and only put the healthiest, most viable genes, which will probably lead to a life expectancy going about 100 years minimum. Another interesting side consequence is probably in physical appearance. Everyone will probably be good looking and will probably be what is, by our standards today, hyper intelligent. There won't be a genetic underclass for the simple reason that these, just like today, you don't have there are gaps, but things like vaccination from polio and things like that are universally available. This technology will probably be relatively cheap and accessible to, if not all, then at least a large segment of the population. We'll probably have cloning as well. So we'll probably have the first example of human cloning within 100 years, and that will not be a big deal. It will be just like the first test tube baby. A clone is essentially an identical twin that is 30 years younger. So anyone who would try to form a race of athletes, well, you know how children react to being pressured by their parents to, or parent in this case, to be skilled in a very specific skill. They would probably rebel. So we're gonna have cloning. What else are we going to have? Nanotechnology, machines doing all sorts of things. Quantum cryptography. We're also going to definitely have quantum cryptography, which is pretty easy to do, and because the hardest part about quantum computers is you need to design a way for different quantum bits to interact with each other. And with simple quantum cryptography, you don't have to do that. So we're going to have quantum cryptographic machines within 10 to 20 years, commercially available. Quantum computer simulations will also be pretty interesting. We'll be able to simulate any sort of quantum system on our quantum computer. That will be lots of fun. And in terms of cognitive sciences, I think we're going to make great strides in a systematic study of happiness and fulfillment. Systematic scientific study on what makes human beings happy, content, how to live one's life, and so on. And in that same vein also a systematic spirituality, an empiric spirituality, how to form experiences in our mind systematically. And we're probably going to make great strides in the science of consciousness, and the science of what it means to be human, what it means to be aware, which centers are responsible for that, how can we preserve it, and so on. Well, thank you for listening.